Hello mathematicians, hope in this video you can say I can write numbers in scientific notation. In this video we're going to go over examples of both writing numbers given in standard notation, writing them in scientific notation, as well as converting numbers that are written in standard or in scientific notation into standard notation. Let's look at a few different examples in this video. So we're given 3,270,000, and that is written in standard notation. So now we're going to convert this into scientific notation. In scientific notation, the first number is always going to be a number greater than 1, but less than 10. So it's just going to be in the ones place. So the first number is going to be 3, okay? And then we're going to write our decimal, and we just write our decimals out until the numbers, until there's a 0 up, you can see. So we're going to write 3.27, and we're going to cut out the rest of the zeros, okay? And we can see that we move the decimal place over 1, 2, 3, 4, 5, 6 places. So this is going to be equal to 3.27 times 10. And when we multiply by 10, remember we're just moving the decimal place to the right. And we're going to do that 6 times. So it's going to be times 10 to the power of 6. So this is in scientific notation right here, 3.27 times 10 to the power of 6. So 3,270,000 is 3.27 times 10 to the power of 6. Now let's look at an example where we are given a large amount of decimal places. So we're given 0.000002845. And again, we're going to move this decimal place right here. So it's going to be 2.845 times 10 to the power, well, we moved it over to the left now, 1, 2, 3, 4, 5, 6 places. So it's like we divided by times 10 to the 6th place. So that is actually going to be a negative exponent. So it times 10 to the power of -6, because we moved it to the left. When you're multiplying by a negative exponent, we're moving to the left. So we're going 1, 2, 3, 4, 5, 6. And remember, when you multiply by a negative exponent, we're actually we could put this in the denominator. We're actually dividing by 10 to the power of 6. But this would be written in scientific notation right here. So now we're given a problem that is written in scientific notation. We're given 4.2 times 10 to the power of 8. So what we'll do is we'll write our 4, and now we're moving it to the right 8 decimal places. Okay, so moved over 1 place, and now we need to add an extra 7 zeros. So we go 1, 2, 3, 4, 5, 6, 7. We need to add 7 zeros to account for the additional 7 places to the right we moved it. So we move it over 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So now we just need to go in and add our commas at the very end. So 4.2 times 10 to the power of 8, we can see is 420 million. Now we're given 7.8 times 10 to the power of -5. So again, written in standard notation. So I'm going to leave some space off to the left. So let's write our 7 and our 8. So now we're just going to move it to the left 5 decimal places. So move to the left 1, and now we need to add our extra zeros. So 1, 2, 3, 4, and 5. So our answer would be 0.000078 written in standard form. So as you can see, this is the process converting between standard and scientific notation is fairly straightforward. Just to clarify some uses for it, the reason that scientists use that is because, well, if you're going to be raising something, maybe it was 3.27 times 10 to the power of 42, you would not want to write out all those place values. It'd take up a ton of space. So it's kind of just a way to keep our work nice and neat and save a little bit of space. So that is why we use scientific notation. So that is it for a video. Hope after watching this and getting a little practice, you can say I can write numbers in scientific notation.